Okay, I'm back, and so now we want to talk about what is mass wasting. So this is going to be the transfer of rock material or soil downslope under the direct influence of gravity. So for the most part on Earth, if this is the surface of the Earth, gravity is going to pull down like that. And if you have a slope like this, and then you've got material like boulders or soil or whatever on it, those particles are going to feel the effects of gravity and they're going to be pulled down slope. So what is it that's going to control mass wasting? Well, the first thing is going to be the slope. So you could have a essentially horizontal slope. You could have a slope that is moderate like this, and then you could have a slope that is very severe like this. So the greater the slope, the more likely materials are going to be pulled downhill because of gravity. It also depends on the nature of the materials. So is it going to be soil? Is it going to be small pebbles and rocks? Or is it going to be big boulders? Or is it going to be entire chunks of rock, entire beds of rock that are going to be slipping? It also depends on, if it's rock, what kind of rock is it? So is it limestone rock? Is it going to be granite rock? So depending on the type of the materials, it's going to behave differently when you subject it to gravity. Okay, it also depends on the amount of water that is in it. So in the case of soil, if you have small amounts of water, that's actually a good thing, because that water will act like a glue that will hold the sediment together and make it less likely to slip. But if the soil has too much water, then that water will separate the various materials so that they're not in contact with each other, and then it makes it easier for them to slip over the tops of each other. Okay, what about vegetation? So vegetation has roots, and those roots can help hold things together and make it less likely that stuff will move downhill. Okay, what about the geological structure? All right, so in this picture that you see down below, you see a anticline and a syncline. So you've got layers of rock that are making a anticline, and then they are making a syncline over here. But then superimposed on top of those beds is the actual surface of the Earth. And you see that the surface of the Earth is doing something like this here. Okay, so if you had debris that's up here, it's going to want to go in this direction, but notice it's perpendicular to the beds. And so that's a particularly stable configuration. So you're not going to have much slippage of this material downhill when it's perpendicular like that. But if you look over here, you will notice that the ground is parallel to the beds over here. So that means that these beds could slip with respect to each other downhill easier. So it depends on the orientation of the beds with respect to the orientation of the ground surface. And then it also depends on, are there natural fractures in the rock? So if the rock is fractured, then it's going to be more likely to pull away and slide. Okay, let's take a break, and when we come back, we'll talk about how are the different types of mass wasting classified.